Hi, I'm Walid Abdelati, and I really appreciate the opportunity to speak at your event today. I am the director of the Cooperative Institute for Research in Environmental Sciences at the University of Colorado in Boulder. We're an environmental research institute, and we study all aspects of environment and environmental change, including climate change, among other things. Now, I grew up in central New York. I grew up outside of Utica. I went to undergrad at Syracuse University. I got my first real job as an engineer at General Electric in Syracuse. And then I went on to graduate school at the University of Colorado, and I worked for about 14 years at NASA in a scientific and also bureaucratic capacity, and then came back to the University of Colorado as a professor and most recently as the director of this Environmental Research Institute. And it really was that time growing up and the memories I have as a kid in central New York of the fields and the woods and the cross-country skiing and the snow, lots of snow, that really gave me an appreciation for nature, for the environment, and I have since made a career out of that. My research focuses on the use of satellite observations to study how and why the Earth is changing, in particular the Earth's ice cover, and I'm going to talk about that in a little bit. I mentioned I worked at NASA. A lot of people when they think of NASA think of the human space program, the going to the moon, the space station, the space shuttle, etc. But NASA has a critical role to play in understanding the Earth environment. The view from space, from satellites of the Earth, of the land, of the ocean, of the atmosphere, the interaction of all of these components really tells a story about how the Earth works, how it's changing, and how those changes affect the way we live. My research focuses on understanding how and why the Earth's ice cover is changing, in particular the ice sheets of Greenland and Antarctica and the Arctic sea ice cover. So using satellites, we're able to watch the evolution of the Arctic ice cover, watch it grow in the winter and shrink in the summer, and see how those change from year to year. And what we can do from space is actually see the extent of this ice, measure the thickness of this ice, and determine its age. And if you look at this figure here, what we see is 1984, which was kind of the lowest ice cover year of the 1980s. The September minimum. The Arctic ice cover reaches its smallest extent in early to mid-September, and this is what it looked like in 1984. And what you see in the whites is that it's mostly old ice, it's thick ice, and you can see the extent where the ice ends and the ocean begins. And this is the ice cover in 2016. And what you notice is a significant change. The ice is not as old, it's younger ice. The ice is thinner, the old thick ice has gone away, and it's far less extensive. This has huge implications for weather, for climate, for ocean circulation, for commercial interests in fishery, for shipping routes across the Arctic as this ice cover opens up. And if we go back to the mid-1800s, we can see from ship records where we think the ice was at the time. And here you see the evolution of the ice cover through the late 1800s, the early part of the 20th century, and up to today. And we are well on our way to an ice-free Arctic in the summertime, maybe in the next few decades. We're not sure exactly when, but we believe it's coming. This is a major perturbation to the Earth's climate system. It's something modern human civilization has never known. We don't know what to expect. We're working to understand the implications for weather, for climate, for drought, for flooding, for storms, for all of these phenomena. But the Earth is changing in dramatic ways, and the Arctic ice cover is perhaps one of the most visible manifestations of that change. Another area that I study using space-based observations is the growth and shrinkage of the Greenland and Antarctic ice sheets and other glaciers in the world. Greenland and Antarctica together contain more than 60 meters of sea level equivalent. Greenland has about 7 meters, Antarctica a little less than 60 meters. And you can imagine, I'm not saying they're all going to disappear in the coming decades, but they are shrinking. We're working to understand how rapidly are they shrinking? Is that ice loss accelerating? Because as the ice leaves the ice sheets, it goes into the oceans and causes sea level rise. This happens from melting, and this happens from the calving of icebergs at these massive, massive outlet glaciers. And using observations from space, we can measure the growth and shrinkage of the ice. We can measure the rate at which it's flowing. We can measure the amount of melt that is occurring in these areas. And what we've seen over time, what our satellites are telling us, are that Greenland is shrinking, Antarctica is shrinking. Greenland is actually shrinking at a more rapid rate. And not only are they shrinking, as you can see in these figures, and on the left is the mass change, how much weight of ice is leaving. On the right is what that is in sea level equivalent, so how much this loss is causing oceans to rise. So what you see in this graph is that they are both shrinking, but what you can also see, if you look closely, is they're shrinking at an accelerating rate. The curvature, the downward curvature of those lines means the ice loss, the rate of ice loss is increasing. Now, we don't know if it's going to increase substantially, if it's going to level off at some point, but we do know the ice is shrinking. And that is contributing to increases in sea level. The height of the ocean is rising. And here you see the trend, again, observed from satellites. We have altimeters on satellites that measure the heights of the ocean. And you can see that the ocean is rising at a rate of about 3.4 millimeters per year. Now that doesn't sound like much. Maybe that's a couple of quarters stacked on each other. But year after year, that adds up. And when you consider the coastal erosion, the fact that as these rising oceans erode the sand at the shores more rapidly, the implications are tremendous. And consider the fact that the last time the climate was this warm, the oceans were 3 to 5 meters higher than they are today. So there's reason to believe that this rate of sea level rise could accelerate, and it could accelerate dramatically. There's about 5-ish meters of sea level equivalent that's kind of poised to spill into the oceans from the ice sheets. And again, I'm not saying that's going to happen. What I'm saying is there is a potential in our future. We're seeing the glaciers speed up. We're seeing the melting increase. So whether the oceans are going to rise 0.5 meter this century, 1 meter this century, which is a little more toward the middle of predictions, or potentially several meters this century, we don't know, but the implications are huge. And let's just consider an increase of 1 meter of sea level rise. Here's a graph or an image that shows the vulnerable coastal areas with respect to 1 meter in sea level rise. And what you see from this is 10 years old. Populations have only increased, but 145 million people vulnerable to displacement from a 1 meter rise in sea level the world over, at a cost of close to $1 trillion. So when we talk about the cost of mitigating against climate change, there is a tremendous cost to not mitigating against climate change. A cost to life, a cost to livelihood, and an economic cost. This is just one example. I've shown you the Arctic sea ice as another example. The satellites are telling us how the world is changing, and they're revealing dramatic changes. Changes in drought, changes in flooding, changes in vegetation health, changes in ecosystem the world over, changes in the amount of energy our atmosphere is storing as the Earth is warming up. These have tremendous implications, and I want to leave you with one thought. I mentioned that my work is in studying polar ice cover, and there's a famous polar explorer, Roald Amundsen, who traveled the harshest, most brutal ice-covered seas of the world, conditions that are unimaginable to most people today. And when asked about his success, how he did it when many others perished, he said this. He said, "I may say this is the greatest factor, the way in which the expedition is equipped, the way in which every difficulty is foreseen and precaution taken for meeting or avoiding it. Victory awaits him who has everything in order. Luck, people call it. Defeat is certain for him who has neglected to take the necessary precautions in time. This is bad luck." We're on a journey. We're on an expedition. And we can equip ourselves to meet the challenges that are likely to confront us on that, or we can not prepare. The choice is ours. And this is why events like this, the efforts of scientists to understand how and why the Earth is changing, the efforts of policymakers to make good policy that can protect us in the face of those changes and allow us to capitalize on opportunities that may emerge is absolutely critical. So I appreciate what you're doing here today, and I appreciate the opportunity to be a part of it. Thank you.